Welcome to Manifest Maths. This is going to start the series on coordinate geometry for WJC Unit 1, AS Level Mathematics. This lesson we're going to focus on finding the gradient, the midpoint and the length of a line connecting 2 points. This is a core and key skill for any A-level coordinate geometry question. So the first thing to consider is to look at some of the formulas. So let's say that we had 2 points, A and B. And let's say the coordinates of A were x1, y1. And the coordinates of B were x2 and y2. Now obviously the location of these could vary, which will then imply that the gradient, the length and the midpoint between those would be in different positions. So there's three things that you need to know, and the first one is what we call the gradient. We sometimes refer to this as m. Now to find the gradient, what you will do is you will find the difference between the y coordinates. So it's going to be y2 minus y1, and then divide that by the difference between the x coordinates. Things to consider: if you are going to do y2 minus y1, then you must do x2 minus x1. Conversely, we could have done it the other way around and had y1 minus y2, but in that case you would have had to do x1 minus x2. The other formula that you need to know is for finding the midpoint between two points, A and B. Now, the coordinates of the midpoint is essentially the average of the two individual coordinates. So to find the midpoint, you would do x1 plus x2 divided by 2. That will give you the coordinates in terms of x. And then y1 plus y2 divided by 2. Now to find the distance from A to B, you will apply Pythagoras. So that will be equal to the square root of the difference between the two coordinates squared. So it'll be x2 minus x1 all squared plus y2 minus y1 all squared. Let's do a quick example then. So let's say we had two coordinates A and B. So let's say the coordinates of A were minus 4, 8. And let's say the coordinates of B were 3 and 12. Now, one thing that I always encourage my students to do is to plot any coordinates you're given on a fictitious or an approximate grid, just to get an idea of whether your answers are going to be realistic. So if you were to plot the coordinates minus 4, 8, let's assume minus 4 is approximately here, and the 8 is approximately here. So we'd have point A in this position, minus 4, 8, and B would be 3 across and 12 up, be here. So I would also encourage you to plot the 2 points and join them together. Now what you'll notice is that line is going up. So what that means is the gradient must be a positive quantity. So for these two, let's calculate what the gradient will be for our m value. Now we're going to assume that this is x1 and this is y1, and that our b's are x2 and y2, and then you just substitute them into the formula. So remembering the gradient is equal to y2 minus y1 over x2 minus x1, which gives us 12 minus 8 over 3 minus 4. 12 minus 8 is 4. 3 minus 4 is 7. And that gives us a gradient of 4 sevenths. Okay. Now, you'll notice that this is a positive quantity. You could convert this into a decimal. It's approximately equal to 0.57. So what that means is, for every 1 across in the x direction that we go, we would go up 0.57 in the y direction, which implies, that it's quite a flat line, and it does look that way in our diagram. Then to find our midpoint, we substitute our values into our second formula, so x1 plus x2. So we're going to have minus 4 plus 3 over 2, and 8 plus 12 over 2. That gives us minus 4 plus 3, which is minus 1, minus 1 over 2, which is minus a half, and 8 plus 12, which is 20, over 2, which is 10. And we can then plot that on our diagram, so minus a half across, be about there, and up to 10. Now you can obviously see from my diagram it's not perfect. That should be the midpoint of there. What's happened in my particular diagram is it hasn't been drawn particularly well. No, sorry, I have plotted it incorrect. It's minus half and 10. So minus half will be here and 10. And you can actually see that it looks more like it's in the middle of those two values. Okay. Then for my distance, that will be equal to the root of x2 minus x1, so 3 minus 4 all squared, plus 12 minus 8 all squared, which will be equal to the root of 7 squared, which is 49, plus 4 squared, which is 16. Then I can add the 49 and 16 together, which gives root of 65. Then what you could do is recognize that that's a surd that can't be simplified. There's no square number that goes into 65. You could then just generally get that as a decimal, which gives you a value of 8.06 to 2 decimal places. And that just gives you an idea of the distance between A and B, and it seems realistic. Okay, we're going from minus 4 to 3, and we've got those three things. So we're going to use these three relationships now to do a few examples, then you're going to try a few questions. So some questions that have been taken from some past paper questions. So for part A, we need to find the gradient of AB. So A has the coordinates minus 6, minus 3, and B has the coordinates 4 and 2. We can decide that's our x1 and that's our y1. This is our x2 and our y2. So our gradient, which we'll call m, is going to be equal to y1 minus y2 over x1 minus x2. Y1 is minus 3, y2 is 2, so it's minus 3 minus 2, over x1, which is minus 6, minus x2, which is 4, which gives us minus 5 over minus 10. The two negatives will cancel here, which gives us a gradient of 5 over 10, or half, or 0.5, depends on which way you'd like to represent them. Now, like I said, a diagram might be useful to check if that's realistic. So if we plot A and B, A would be at -6, -3, down here. B would be at 4 and 2. And if we join from there to there, we see that it's quite a flat line. It's certainly not perfectly diagonal. That would be a gradient of 1. It's not flat. So we see that our gradient seems realistic. Okay, part B. Find the lengths of AB and AC. Hence find the value of the constant K such that AB equals KAC. So, first step is to find the distance from A to B. That will be equal to the square root of x1 minus x2, so -6 minus 4 all squared, plus -3 minus 2 all squared, which should be equal to the root of -6 minus 4, which is -10, -10 squared is 100, plus -3 minus 2, which is -5, and -5 all squared is 25, which gives us the root of 125. Now in this particular case, this can be written as 25 times 5, which is root 25, root 5, and that can be written as 5 root 5. So that's our first distance. We also need to find the distance of AC. So now we're going to assign x1, y1, x2, y2. We've got the square root of -6 minus -2 all squared, plus -3 minus 5 all squared. That's going to give us the root of -6 minus -2 becomes -6 plus 2, which is -4, and -4 squared is 16. And -3 minus 5 is -8. -8 squared is 64. This gives us root 80. And root 80 can be written as 16 times by 5, which is root 16 times root 5, which gives us 4 root 5. Now the question is asking for us to find the K value, and it says that the distance from A to B is equal to some constant times by the distance from A to C. Well, the distance from A to B we've established is 5 root 5. The distance of A to C was 4 root 5. We can divide both sides by root 5, and then bring the 4 underneath the 5. So K is equal to 5 over 4. And then finally, part C is the midpoint. Okay, so we're going to apply our averages. We want the midpoint of AB. So it's going to be -6 plus 4 over 2. Then -3 plus 2 over 2. Which gives us -6 plus 4, which is -2. -2 divided by 2 is -1. And then -3 plus 2 is -1. And -1 over 2 is -1/2. We could just check on our diagram that seems realistic. So -1 and -1/2, which puts us about here, and you can see that it is the midpoint. Okay, right. Here's a question for you to try that. Give this one a go. So the gradient of AB for part A. We're going to define our x1 and y1, x2, y2. Let's plot them on a diagram to see where they are approximately. So A is at minus 7, 3. So minus 7 and 3 up. And B is at 2 cross 0 down. So it's here. So we should have a negative gradient for this one. So our answer should give us a negative value. We're going to do y1 minus y2 over x1 minus x2. We could have done it the other way around, y2 minus y1 over x2 minus x1. So y1, which was 3, minus y2, which is 0, over x1 minus 7 minus 2, which gives us 3 over minus 7 minus 2, which is minus 9. That fraction can be simplified to a third. So the gradient is minus 1/3. Then part B. Find the lengths of AB and AC. Hence find the value of the constant K such that AB, KAC is equal to each other. Give your answer in its simplest form. So first one is to find the distance AB, which is equal to the root of minus 7 minus 2 squared plus 3 minus 0 squared, which gives us the root of minus 7 minus 2 is minus 9, minus 9 squared is 81, 3 squared is 9, which gives us root of 90. This simplifies to 3 root 10. Then we're going to work out AC, which is equal to the root of minus 7 minus 3 squared plus 3 minus 5 squared, which equals the root of minus 3 minus 7 minus 3 is minus 7 plus 3, which is minus 4 squared, plus 3 minus 5 is minus 2 squared, which gives us the root of 16 plus 4, which gives us root 20. And then we can simplify the root 20 to 2 root 5. We can then put AB equal KAC, so it'll be 3 root 10 equals K times by 2 root 5. We're going to make K the subject, so we can bring the 2 root 5 underneath the 3 root 10. So that's going to give us K equals 3 over 2 times by root 10 over root 5, which gives us 3 over 2 times by root 2, and we can leave that as our answer. Midpoint of AB, so minus 7 plus 2 over 2, and our y coordinates will be 3 plus 0 over 2, which gives us minus 7 plus 2, which is minus 5 over 2, which is minus 5 over 2, and 3 over 2. Okay, so these are 3 questions for you to give a try, and then we'll go through the answers on the next page. So the first question, I'll take, find the gradient of AB. So we're going to put M equals, label these x1, y1, x2, y2. So we're going to have minus 2 minus 12 over 10 minus 3. Minus 2 minus 12 is minus 14. 10 minus 3 is 7. 14 divided by 7 is 2, so this gives a gradient of minus 2. Our length, notice I've taken part B out of this question. So part C, find the length of AB. A to B would be equal to the root of minus 2 minus 12 squared plus 10 minus 3 squared, which gives the root of minus 14 squared, which is minus 196, plus 7 squared, which is 49, which gives us the root of 245, simplifies to 7 root 5. Part D. Point D is the midpoint of AB. Find the coordinates. So to find the midpoint of AB, so it's going to be minus 2 plus 12 over 2 and 10 plus 3 over 2. Minus 2 plus 12 is 10, and 10 divided by 2 is 5. And then 10 plus 3 is 13. 13 over 2, 6.5. Quick little sketch to see if our answers make sense. The coordinates minus 2, 10. So minus 2 and 10 will be up here for A. Then 12 across and 3 up would be here. And I've just noticed my mistake. This is right, so this is clear why you need to draw the diagram. So I had a gradient. So let's check the midpoint first. Midpoint was 5, 6, and that seems realistic. Yeah, 5, 6. Now my gradient doesn't seem right, okay? Because it doesn't look like a steepness of minus 2. Remember, a steepness of minus 2 is for every 1 across, we go 2 down, which implies quite a steep line. The mistake that's been made here by myself, because I'm an idiot, is that I've done x1 minus x2 over y1 minus y2. So it should be the other way around. Okay, so the gradient was actually 7 over minus 14, which was equal to minus a half. So my gradient was wrong. Okay. So that emphasizes why a diagram is important. See if I can do this one without making a mistake. Find the gradient of BC. So x1, y1, x2, y2. We want to find the gradient of BC. So m is going to be equal to y1, which is minus 5, minus 7 over 6 minus 3, which equals minus 12 over 3, which equals minus 4. So let's check that one. On our diagram, the coordinates 6 minus 5 for point B, and then 3, 7. You can see there's a very steep line coming down, so our gradient seems and feels correct. The length of CA. This time we're going to use A and C. Now the root of 8 minus 3 squared plus 4 minus 7 squared, which is the root of 5 squared, which is 25, plus 4 minus 7, which is minus 3 squared, which is 9, which gives us the following, root of 34. And then part D, midpoint of AB. So it's going to be 8 plus 6 over 2, and 4 plus minus 5 over 2, which is 14 over 2. 4 plus minus 5 is 4 minus 5, which is minus 1 over 2. So our midpoint is 7 and minus a half. So given that, so this is the midpoint of AB. So where's point A? This is our point B here. Point A was 8, 4. And our midpoint was 7 minus a half, which is about there, and it seems about right. Okay, last question. The gradient of AB. So x1, y1, x2, y2. The gradient of AB is going to be equal to 7 minus 1 over minus 4 minus 2. That becomes 8 over minus 6, which is minus 4 over 3. So it's a negative gradient of minus 1.3 occurring. See if it makes sense. Y and x. So minus 4, 7, for point A, 2 and minus 1 for point B, and it seems like it's a line that's going down. For every 1 across, we go 1.3 down. Part B, find the coordinates of C, which is the midpoint. So that's going to be minus 4 plus 2 over 2, combined with 7 plus minus 1 over 2. Minus 4 plus 2 is minus 2, divided by 2 is minus 1. 7 plus minus 1 is 7 minus 1, which is 6. 6 over 2 is 3. So our midpoint is minus 1, 3, which is about there. Seems correct. And C, the length of AB, root of minus 4 plus 2 squared plus 7 minus, oops, sorry, I made a mistake here. Minus 4 minus 2, sorry, and 7 minus 1, which is equal to the root of minus 4 minus 2 is minus 6. Minus 6 squared is 36. Plus 7 minus 1 is 7 plus 1, which is 64. 36 at 64 is 100. So it gives us the length of root 100, which is equal to 10. Okay, right, so back to the first question. Just to summarize this quick lesson. So part A, the gradient of AB. So that's going to be equal to 7 minus 13 over minus 2 minus 6, which is minus 6 over minus 8, which gives us 3 over 4. The length of AB, root of minus 2 minus 6 squared plus 7 minus 13 squared, which gives us the root of minus 8 squared, which is 64, plus 7 minus 13, which is minus 6 squared, which is 36, which gives us root of 100, which again was 10. And the midpoint of AB is minus 2 plus 6 over 2, 7 plus 13 over 2, which gives us 4 over 2, which is 2, and 20 over 2, which is 10. Okay, so the next video in this series is going to be on using these elements to find equations for straight lines. Okay, very common question on Unit 1 coordinate geometry.